Hello. So now I'll be looking at a very interesting question from the topic of sound and motion, which comes under time, speed, and distance. In the question, there is an object which is going towards the source of sound, which emits two waves at a certain gap, and then because that person is approaching the source, that person will hear it in a shorter. The gap will be shortened rather. So the question states that two guns were fired from the same place at an interval of 10 minutes and 30 seconds, but a person in a train approaching the place hears the second shot 10 minutes after the first. The speed of the train in kilometers per hour, supposing that sound travels at 330 meters per second, is. The first way to solve this question is by visualizing that the gap is reduced in this case, and it would obviously be because the person is traveling towards the source. So what would have taken 10 minutes and 30 seconds between those two, between the sounds from those two guns, is taking 10 minutes only, and this is because of the movement of the train towards the source. So we can say that the train is moving for 10 minutes and the sound is moving for 30 seconds, and both of them travel the same amount. This is very difficult to visualize, and it's probably very difficult to interpret, but then again you can say that distance covered by the train in 10 minutes. So distance covered by the train in 10 minutes will be equivalent to the distance covered by sound in 30 seconds. So this is a very important observation, and it's very important to understand this. So as soon as you get this, it becomes very easy for you to solve it, because distance covered by sound in 30 seconds is very easy to understand. It's nothing but 9,900 meters, which can be seen from this bit of information. And distance covered by the train in 10 minutes will be equal to whatever the sound covers in 30 seconds, which is equal to 9,900. So the train is covering 9,900 meters in 10 minutes. Right. So if the train is covering 9,900 meters, which is nothing but 9.9 kilometers in 10 minutes, then the train will cover how many kilometers in 1 hour? That is 60 minutes. So you have to simply multiply it by 6. You will get 6 9s are 54, and again 59.4 kilometers per hour. That will be your answer. So it's very easy if you can proceed along if you can visualize this thing. But then again, it becomes very difficult to understand this and to follow this during an exam scenario. So what you can do is that you can visualize it as another time speed distance question. So let's make sure that this is the line along which the train is traveling. Let this be the source and let this be the train. So the train is traveling in the direction of the source, and the source is emitting sound waves in this direction, right? So what happens is that let's visualize it from a smaller perspective. Now the sound wave has been emitted and the train is traveling towards the sound wave, right? So we can understand. So what we can understand is that let the train meet the sound wave somewhere here. Now the first sound wave has reached here and the train has also reached here. So the train and the first sound wave will meet somewhere at this point, right? Now when they meet at this point, the second sound wave had been sent at a gap of 10 minutes and 30 seconds. So the second shot or the second sound wave was somewhere here, and the gap is nothing but 10.5 minutes. So we are thinking of this in terms of time. So you can visualize it as when the second shot was fired, the first shot had already moved for 10 minutes and 30 seconds at the speed of 330 meters per second. So that is a very important observation. Now what happens is that if the distance is in terms of time, and we also know the speed, which is 330 meters per second, we can easily find this distance. Now for the moment, we will not really get into solving this question, because we will see that a few terms cancel out. So if the speed of sound is 330 meters per second, we will simply write 330 meters per second here, just like that, and we will simply multiply it by the time that has passed. So because this is in meters per second, we will put this in terms of seconds, which is nothing but 630, because 10 minutes and 30 seconds is nothing but 630 seconds. So this is the distance that has to be traveled. Now what happens is that this distance is being traveled with a relative speed of the train and the sound wave, which are traveling in opposite directions, and so we will add those speeds. So we have to find the speed of the train, because we do not know it. We will assume it to be x. So let's say that the speed of train is x. Now speed of train is x and the speed of the sound wave is 330 meters per second. Then this is the effective speed with which they will be covering this distance, and the distance remains the same. But what is happening is that they are covering this distance in a period of 10 minutes, right? So the train is meeting the first sound here, and it's meeting the second sound here, and this gap is being covered in 10 minutes. So for 10 minutes, both the train and the sound wave are in motion. and because they are in motion in opposite directions, we will add their speeds and we will simply multiply it by the time, which is nothing but 600, because we are dealing with meters per second here, so we will be careful about how we convert it. So if we can cancel it from both sides, this is nothing but 21 times 30, and this is nothing but 20 times 30. Again, you can simply cancel 0 and 0 from here. So we will effectively get 21 into 33, which is nothing but 693. You can simply do 21 into 363 into 11 is 693. You can easily get it. Is equal to 2x plus 660. So we will get x will be equal to 33 by 2, which is nothing but 16.5. So x is 16.5 meters per second. Now, once we get this thing, we can simply use the calculator, or we can simply multiply it by 18 by 5, and we can get it in terms of kilometers per hour. So you can simply see that 16.5 into 18 divided by 5 will be nothing but 17 into 9 by 5, which is 33 into 9 divided by 5, which is nothing but 297 divided by 5, which will again be, you can easily calculate it to be 59.4. So you can simply say that it's 297 by 5, and you can see that 5 5s are 29, 47, again 5 9s are 45, and 20 will remain, so we can simply put 0.4. So that will be your answer. So in both cases you will get the answer as the same thing, but it's probably easier for you to visualize it like this than probably do it in this manner, because this requires a lot of visualization. So you have to understand that the distance covered by sound in 30 seconds will be equivalent to the distance covered by the train in 10 minutes, and then you will have to find it out. So one thing you can do is you can take the gap, the smaller part will be covered by the sound, and the larger part will be covered by the person or the object that is moving towards the source, and then you can solve it. Or probably it would be a good idea to solve it in terms of a time speed distance question, because once you know 10.5, you can simply put 10.5 here. It becomes very easy for you to visualize where 10.5 will be. So 10.5 will be the gap between these two, which was the gap at which these two sounds were sent, and this distance will be covered by adding the speeds of the train or the object which is moving towards the source and the sound wave. So then this equation becomes very easy. Once you solve 2 or 3 questions on this domain, you will be able to figure out this equation in a matter of seconds. And then once you figure out this equation, the question becomes very easy, and you have to simply keep in mind what the units are and how to solve this question, and you can easily end up with the answer, which is 59.4 kilometers per hour in this case. So this is a very interesting question, and if you practice more of these type of questions, then you would probably see that you will get a lot of questions from this area which are correct. You can expect one question from this topic. You can, at max, one question can appear in a CAT test. It's definitely one of the tougher questions, probably something on the lines of 700 plus questions which are seen in the GMAT. So if you know this question, it will be the differentiator between you and someone who is getting a 99.5%.